Let's consider the following problem. Consider a semicircle, which is half a circle, with total charge q and radius r as shown below. What is the electric field at point P? All right. So to do this example, let's consider the master formula again, which is the integral, which is the electric field, and a point P is equal to the integral of basically k, which is Coulomb constant, dq over rp squared rp hat. Right. Okay, well, let's basically just consider this thing very simply now. All right, so this is a uniform charge q, so let's consider arbitrary point here. All right, so this has a certain length of basically ds. All right, so that's the arc length, and the radius of this thing is going to be capital R. Now, from this point to point P, this vector here is RP vector, right? So, if we want to draw this arrow a little more clearly here, right? So if we want to basically write down what RP vector is, well, this is basically just RP vector is simply going to be equal to basically the length times the direction. So how do we get the direction? Well, let's adopt the little coordinate system here. Let's call this basically x and y. All right, and let's think about this fairly carefully. Okay, let's put um, uh, it doesn't really matter where the origin is, but we're gonna pick the origin at basically point P for now, right? And so this will be x, this will be y, and I'm gonna pick the angle theta measured from the negative x-axis. So it'll be theta there, right? Okay, so what's RP going to be? RP is just gonna be, well, it's just the R component this way, so that's be RP is pointing this way, so that's that. So it'd be capital R, right, which is the length. So the length of this vector will be capital R. Cosine theta, right, times x hat plus now the y part r sine theta, and this vector is pointing in this direction out, so it'd be in the minus y hat direction. All right, and so basically rp hat is just going to be rp vector over rp. All right, but rp is just going to be r, right? So this is just going to be basically cosine theta x hat minus sine theta y hat. All right, and then we're done. And then basically, of course, note that before rp is simply equal to r in this example. All right, now that gets us most of the way there. Now we just have to figure out what dq is, right? So dq is just going to be basically the entire charge per unit length, which we'll call lambda, times ds, right? And ds is just going to be this arc segment here, which is just going to be basically capital R times d theta, right? Okay, and then finally this one is just going to be q over the total length, which is going to simply be equal to q divided by what's the length of half a circle? Well, a full circle is 2 pi r. Half a circle is going to be pi times r. All right. Okay. So with this in mind, let's go ahead and solve this thing. So this is now equal to, let's plug each one of these terms in. Okay. So I'm going to be integrating over something. All right. We'll figure out what that is going to be a second. K. What's dq? Well, that's just going to be, I'll leave it as lambda for now, times ds, which is r d theta, and this is divided by rp. That's very simple, r squared, and then rp is just going to be cosine theta x hat minus sine theta y hat, right? Now, there are two ways to argue this thing. First, but I'm going to give you the simplest argument. All right, so the first thing we have to do is basically find the limits of integration. All right, so cosine theta, when theta is up here, is going to be pi over 2. and when it's down here, it's going to be minus pi over 2. Right? So this is actually from minus pi over 2 to pi over 2. Right? And so basically there are two components of this. Right? You can show that this component, the y component, is going to be equal to 0. And there are two ways of showing this. One is just do it. Second way is basically note if you flip this thing upside down, right, you get the same problem again. And so therefore, if that's true, if the E field was pointing this way, now it'll be pointing that way. But the same problem, so it has to be pointing in the same direction again. So in that case, what happens? The only case that would be true if there's no E field in the Y direction. Right? Okay, so what we have left is that this is going to be irrelevant. This is going to go to 0, right? And so we have just this term left. So it's going to basically be minus pi over 2 to pi over 2 k. Okay, let's do q over pi r cosine theta d theta x hat divided by r squared. Okay, so this r will kill this r, and so what we're finally left with is going to be k q pi r squared integral minus pi over 2 to pi over 2, right, times cosine theta d theta. Okay, of course everything in the x hat direction, right? And of course you do this integral here. This integral here is just simply 2, right? So you're done. 2kq over pi r squared x hat. Okay. All right. Hope that was helpful.